Data visualization. People have an easier time understanding patterns and trends of information if it is displayed visually. Data can be visualized in a number of different ways: bar graphs, pie charts, line graphs, scatter plots, and images. Visualizing data is useful in many industries like science, government, sports, agriculture, music, and medicine. Visualizations can be used to make predictions about events occurring around the world. Answers to questions can be found by sorting through data displayed in visualizations. Patterns can be easily seen through visualizations. An increase or a decrease in growth can be shown in visualizations. A visualization is much easier to read and gather information from than reading entire documents or spreadsheets. Here we have a graph of y equals x squared. What can we learn from the visualization provided? What do you think some of the metadata would describe? Is this visualization as accurate and unbiased as possible? Here we have a line graph that shows the amount of homeless children in the United States in millions. What can we learn from the visualization provided? What do you think some of the metadata would describe? Is this visualization as accurate and unbiased as possible? Here we have a map of the world, and the countries are colored in based on different sports. What can we learn from the visualization provided? What do you think some of the metadata would describe? Is this visualization as accurate and unbiased as possible? Visualizations of data can be skewed based on the number scales plotted on the axes or by leaving out data. Notice how on the chart the y-axis scale does not start at 0, it starts at 15%. This is a misleading chart as it does not make it clearly known where the scale starts. Many viewing this data would assume the y-axis begins at 0. Based on the intent of the visualization, there may be some bias. Bias can come from the company creating the visualization or from the group of programmers who developed the algorithm to express the visualization. Why would there be a bias in the information? If a company is marketing for the purpose of selling goods or services, they would want to promote their product. In some marketing plans, that means only showing information that highlights the positive aspects of their goods. In the same plan, that may also include showing how other comparable goods don't measure up to their standards. Examining metadata is one way to combat bias that may exist in visualizations or marketing plans. By examining metadata, the consumer is better able to understand the data. What is the source of the information? How many sources were polled for information? Was there a range of people surveyed from each source? What is the purpose of the visualization? It is important to remember that programming does have limitations. An algorithm can only be designed to search, sort, and manipulate the data that it receives. This is limited by the number of sources or the quality of the data collected. If a program does not have enough data to draw a conclusive result, it will only output what it is capable of concluding. Oftentimes, when these situations arise, additional research is needed to find a solution. This may mean looking outside of programming to find a solution. Since computer programs are developed by people, a programmer's bias can sometimes cause inherent bias in the programs that they write. Programmer bias can be seen in the types of inputs a program accepts or recognizes. It can also be seen in the test groups of people that are used prior to an algorithm being released to the public. If a test group is made up of only males and females with ages ranging from 18 to 30 years old, and the algorithm is then released to the public, an individual of age 55 years old could have provided a much different input than the test group. If a program asks for the user to input their hair color, but the programmer doesn't consider the color black as a possible choice, that shows a bias in the programmer's logic. There are times when an algorithm cannot be created to find a solution to a problem. As programmers, this concept needs to be understood. A decidable problem is one where an algorithm can be constructed to find a correct solution for all inputs, like is the number even? An unsolvable problem is one where an algorithm cannot be constructed to find a solution. An undecidable problem is a problem where there isn't an algorithm that could be constructed that will always give an accurate yes or no output for every input. Can you think of examples for an unsolvable or an undecidable problem? An example of an unsolvable problem or an uncomputable problem is developing a program that could find the last Fibonacci number. Since the Fibonacci sequence is a repeating sequence of numbers, there isn't an end to the sequence. This would be an example of a problem that could not be computed or solved. An undecidable problem would be one like developing a program to find a matching vaccine for the flu virus. We know that the flu vaccine is capable of fighting some strains of the flu, but we also know that people still get the flu. What we can infer is that the flu vaccine does not protect against all strains of the flu. This outlines an undecidable problem. A program to find a vaccine match to prevent the flu would sometimes find a match, but there would be many strains of the flu that the program would not be able to match.